Okay, so in Calculus 1, students, the third part of the video I'm going to make for this section goes through some physics examples, and we're going to look at the idea of what it means for net displacement and a total distance traveled. So it's an application of an integral primarily. So what I want to kind of go through and do on this problem, first of all, this says you have a velocity given by 3t minus 5 for a particle in motion from time equals 0 to time equals 3. We're going to find the net displacement of the object. A good way to look at the problem at the beginning is to just look at the graph, which this is a linear function. So I'm going to go ahead and put in, let's see, 3x minus 5. We're going to just use the graphing calculator and get a pretty good viewing window on this. And let's see, we're doing the displacement from 0 to 3. So I'm going to do, whoops, don't want to do that. So I want to do a window, let's just do something like -5 to 5. And scale that maybe, let's say something like -10 to 10. And see if we got a pretty good picture of how the graph goes. Because there's one main thing you need to see on this is part of this region of area may be below the curve and part of it may be above. And you can see that you have this little piece below and then you have some above like that. So what I'm going to do is I'm going to just go over this graph and what this means first of all before I go to the next page and actually use the calculus to solve the rest of the problem. Okay, so what's going on this problem is this is a velocity function, so this is v of t. We're interested in going from 0 to 3, so there's 3. So if you look at the area that's taking place, there's really two regions. There's this region here that's below, and then there's going to be one other region, so I'm going to go straight up to 3 and then just highlight this in blue. So what we're trying to do on this total displacement is we're trying to find that net change in area that goes from there to there. So that's what the meaning of this problem is basically going to be, is we need to find that area from 0 to 3. Okay? So let's go to the next page and let's go ahead and let's go through and do that then. So we're going to do two things. We're going to do the displacement. So I'm going to go ahead and do that part first. Okay, so if you're doing the, we're going to find the net displacement, and then we're also going to find the distance traveled. So let's do the net displacement first of all, just so that you see the difference between the two. Okay, so the net displacement is going to be this, okay, and all you're doing is going backwards. You remember v of t, the velocity, is the derivative of the position function. You have, the velocity is really just the derivative of s prime of t. Okay, so it's you do the derivative of s, you get the velocity, and then remember the acceleration is the derivative of the velocity. So we're kind of going in reverse. We're given the velocity and we want to find s of t. So what we have is s of t is going to be what we're going to use for the displacement typically in physics. And what we're going to do is we're going to formulate an integral. So s of t is basically just going to be the integral of v of t dt. Okay, and what we're going to do on this is we're going to get s of t, we're going to go ahead and just work out this integral to find this net displacement from 0 to 3. So we're going to do the integral from 0 to 3 of 3t minus 5 times dt. So this is a definite integral we're going to work out just basically with fundamental theorem of calculus. Okay, so let's go ahead and let's get the antiderivative, so we can do that easy enough. So the antiderivative would be 3t to the second over 2, and then the antiderivative of 5 is 5t, and then we're going to evaluate that from 0 to 3. Okay, and then that'll give us the net displacement. Okay, so what we'll have here is, let's do the fundamental theorem. We're going to evaluate 3 first. So we have 3 times 3 to the second over 2 minus 5 times 3. Then we're going to evaluate at 0. So we have 3 times 0 to the second over 2. and minus 5 times 0. Okay? All right, let's work out the arithmetic. So this is 3 times 9 over 2 minus 15. This whole stuff right here, of course, is going to go to 0. So this stuff there just goes to 0. You can do that in your head. So it looks like you're going to have 27 over 2 minus 15. And then I'm just going to use a calculator on that and get a decimal value on that then. So 27 over 2, we'll change that to a decimal, get that, and then minus 15. So we're going to have a net displacement that's negative, and I'll explain why that is. So we basically have negative 1.5, and what we just found is that displacement, which is in meters. This problem did say that you were in meters. So that's the answer. Now, if you go back to the graph on the preceding page, the reason that you got a negative answer is because you can tell by looking that this area here, which is represented by a negative, and this area here represented by a positive, you can tell that there's more area, there's more of a region below the x-axis than there is above, so that net change ends up being negative. So displacement can be negative, okay, because it has to do with the direction you're going in. Second part of this problem, what I want to do is we're going to do the distance traveled. So we're going to go ahead and find the total distance traveled, and this is a little bit different. All right, and we do need to look at the graph it's pretty important to look at it on this. So what you end up doing on this is if you go back to this previous graph, we don't want a negative there. If we're going to do distance traveled, we want to find this area, but we want to use a positive answer for it, and we want to find this area, which you're already going to get a positive answer for. So actually, when you're doing the distance traveled, technically what this is going to be is we're going to do the integral from 0 to 3, but we're going to do the absolute value of 3t minus 5 dt because we want a positive value to be represented for that area under the curve. So actually the way you got to do this is you got to do this like this. The first thing, if you look at this graph, is we need to figure out what that intersection point is right there. Okay, so we're going to solve that and find what that is. And I'm going to go ahead and just do this right here. So what I need to do is just take that equation, 3t minus 5, and I need to find an x-intercept. So to find an x-intercept, I just set that equal to 0 and solve this equation. So I'd have 3t equals 5. I can divide by 3, so I would get t equals 5/3. So that key number right there is 5/3. So when we do our integral, we're going to be integrating from 0 to 5/3, and then we're going to be integrating from 5/3 to 3. Okay, like that. That's the way I'm going to go about doing that problem. So when I put this together, I'm going to break this up like this. 0 to 5/3, and I need to make sure that I do the absolute value of whatever that answer to that integral is. Then I'm going to go from 5/3 to 3. I don't have to worry about the absolute value there, again, because that's a positive region anyway. So I want to kind of display this so you can see the graph at the same time here. So this part right here, we have to do the absolute value of 3t minus 5. And this part right here, it's already positive. The area is already positive, so we just do 3t minus 5 on that. So hopefully that makes sense to you, what we're going to do. So we're going to work out actually two integrals and get a grand total of these two things. So that's all we need to see on that graph. It's real important on a problem like this that you look at that graph and make that determination if you have some regions below the x-axis. So we're going to start off by I'm just going to split this up and do two parts. First of all, I'm going to work on the integral 0 to 5/3, 3t minus 5 dt. Now, if it's an absolute value, you're still just going to do the antiderivative. So that antiderivative is 3t squared over 2 minus 5t. We're going to evaluate that from 5/3, but what you're going to encounter is you're going to get a negative answer, so you need to use a positive on that. Okay, so let's go ahead and do that. So we're going to do 3 times 5/3 to the second over 2 minus 5 times 5/3. And then we're going to subtract 0, evaluate at 0, so we have 3 times 0 squared over 2, and then minus 5 times 0 like that. So again, what we're doing is just plugging in the limits. And let's go ahead and run through the details on that then for our first integral. So this looks like this is 3. If you take 5/3 to the second, 5/3 times 5/3 is going to be 25/9. So I'm going to write that as 25 over 9. And then I'm dividing by 2. So you're really multiplying by a half. And this second thing right here, of course, would be 25 over 3. And you can tell in your head that all this stuff right here goes to 0. So you don't have to worry about that anymore. So what we'll have is, on this, I'm going to reduce this fraction. 3/9 reduces to 1/3. So what I'll end up having is I'll have 25 over 3. If you divide by 2, you're really multiplying by a half. So we'll have that. And then I have minus 25/3 like that. And let's see kind of how where this leads then. So I've got 25 over 6 minus 25 over 3. Looks like I need to get a common denominator. So I'm going to multiply this by 2 over 2. And when I do that, I get 25 over 6 minus 50 over 6. So that will give negative 25 over 6 then for that region. Okay? All right, now remember, we don't want that. We want the absolute value of that. So what we end up getting then as our conclusion is the integral from 0 to 3 of the absolute value of 3t minus 5 dt is the absolute value of negative 25 over 6. So that's 25 over 6. Okay, so that's an important piece. That's part of the distance traveled we're going to do. All right, now the next thing what we need to do is do the second integral. So we're going to go ahead and do that. So now we do the integral from 5/3 to 3 of 3t minus 5. We don't worry about absolute value because the answer is going to be positive anyway. Okay, so the antiderivative again is 3t squared over 2 minus 5t. And we need to evaluate that from 5/3 to 3. Okay, so let's go ahead and do that. So it looks like we'll have 3 times 5/3. Whoops, I got to do the upper limit first, so I need to be careful and do this in the right order. So plug in the 3, so we'd have 3 times 3 to the second over 2 minus 5 times 3. Then we'll plug in the 5/3, so it's 3 times 5/3 to the second over 2 minus 5 times 5/3. So we need to work out the arithmetic on that then. So let's go ahead and finish that up here and see what we get. Okay, so this is going to be 3 times 9 over 2, 3 squared, minus 15. Over here, kind of like what we did before, this you can just write this as 3 halves. And then 5/3 to the second is going to be 25 over 9. And then this part right there is going to be 25/3. So we can do that. So it looks like we get 27 halves minus 15 minus, whoops. Okay, then I want to have minus. See, I can go ahead and reduce this fraction here to 1/3. So it looks like I would end up getting, let's see, 25 over 6 minus 25 over 3, like that. And then we can get a common denominator and just work all the details of that out, and we'll be ready to get our final answer. And so you get into this fraction arithmetic all the time when you're doing definite integrals, so you want to be aware of that because that's going to show up some. So from here I've got 27 over 2 minus 15 minus 25 over 6, and then plus 25 over 3. And then we can go through and just get a common denominator on all this. You can also do this on a calculator, but I'm going to go ahead and just, do it the old-fashioned way and get common denominators. Our common denominator is 6, so I'm going to multiply the first fraction by 3 over 3. And then the second one, 15 over 1, that needs to be multiplied by 6 over 6. And then the last one, I've got 25 over 6. That's got the correct common denominator. And then the last one, we need to multiply that by 2 over 2. Okay, so it looks like what we're going to get here is this first fraction, that's 81 over 6. This one is 90 over 6 minus 25 over 6 plus 50 over 6. So I'm going to go ahead and work that out. I'll just punch it in my calculator. 81 minus 90 minus 25 plus 50 is going to be 16. So let's see, when I calculate this, it looks like what I ended up getting was 16 over 6, which reduces to 8/3. Okay, so what we're ready to do now is just add those two numbers together. So what we would have is the total distance traveled would be 25/6 plus 8/3. Okay, we can get a common denominator here. So I'll multiply by 2 over 2. Okay, and that's going to give me now 25 over 6 plus 16 over 6. So that's 41 over 6. And if I do 41 over 6, that's approximately about 6.83, like that. So in meters, that would be the total distance traveled. So there's a lot of arithmetic on this, and this is what you get into in definite integrals. And don't forget that you can do so much of this with a calculator. I mean, you can put all this stuff in like this, and I want to show this to you just real quick because it's kind of important. It'll save you some time. If you got down like to this stage right here, okay, if you look at this point in the problem right here, if you just went to your calculator and did 27 divided by 2 minus 15 minus 25 over 6, and then plus 25/3. Okay, you'll get a decimal, but then you go math, convert to fraction, and it'll give you 8/3 anyway. So you got a real quick way to always go through and check and verify your arithmetic when you get into this. Okay, so I do want to show you, this is the final answer of the problem then, right here. Here's how you would check the answer. I got the graph on my calculator, so first thing I would do is I'll do the integral, but I'm going to do this from 0 to 5/3. That's the one we did the absolute value of. Okay, that's shading in this region, and that gave 4.16 repeating sixes. That's what 25 over 6 is. Okay, and then I would also go through and do the same thing, and I could go option 7. Now I would do the integral from 5/3 to 3. That would shade in this region. That's 2.6. That's what the 8/3 is. Okay, so that's the idea, is you have to break that up into two pieces. Okay, all right, so hopefully that makes sense to everybody. Okay, so I'm going to move on and do this example down at the bottom of the page. And with this one, we're looking at this one says, suppose a particle moves along a straight line with a velocity given as this linear function, v of t is equal to 4 minus 2t on the interval 0 to 2. We're going to find the displacement at time t and the total distance traveled up to 2. Okay, so this is kind of the approach of this problem then, is you're given that v of t is equal to 4 minus 2t. Now, if you're finding the displacement at time t, that's just an integral, and that's going to be the integral of this velocity, but we're going to integrate from 0 to t. Okay, that'll give you the function for the displacement. Okay, so we're going to work this out then, and when I go through and do this, we should get what that answer is. Now, one thing I want to correct myself on here is technically the way this needs to go is we'll say this s of t is the integral from 0 to t of v of s ds. Okay, because the t is going to change the variables when we evaluate it. So technically you're doing s, and we're just going to go ahead and do this integral. So we're doing the integral from 0 to t, and we're doing 4 minus 2s ds. Okay, I'm just changing the variable. I can use any variable I want to, just kind of a intermediate variable. So when I do that, the antiderivative is 4s minus 2s squared over 2, and then that gets evaluated from 0 to t. Okay, so I end up getting 2's cancel out. I've got the antiderivative 4s minus s squared evaluated from 0 to t. Now, by the fundamental theorem, I plug in the t now, so now I get 4t minus t to the second minus 4 times 0 minus 0 to the second. Okay, so that's going to give 4t minus t to the second. All this stuff here, of course, is 0, so that's what you'd get. So your function s of t for the displacement is just going to be 4t minus t squared. Okay, so that's what we get there. So that's just a basic integral right there. Okay, now what we're going to do next is we're going to do the distance traveled. And if you want to do the distance traveled on this, you could do, and again, what we're doing on this is we're just going from 0 to 2. Okay, so what I'm going to do is I'm going to graph. Now we can do this like this. There's a couple of ways that you can actually go through and do this. So I'm going to pull up my calculator and I'm going to graph this 4 minus 2t just in the same window I've been using, and I get this graph right here. Okay, so let me slide this thing over here and just interpret kind of what's going on in this problem. So kind of like the last problem, what you have is you're really finding this area under the curve from 0 to 2. Okay, so you're just looking at this region right here. So two ways to do this. Okay, we've already done the antiderivative, so what we could really do to find this distance traveled is you could do it one of two ways. So you could go like this. You could do the integral of 4 minus 2t dt from 0 to 2, and you wouldn't do absolute value because that area is already above the x-axis. So we've already got the antiderivative on that when we did that. So if we do that, we would have 4t minus 2t squared over 2. So you would get the 4t minus t squared anyway. So we already did that. So if we just take that antiderivative and evaluate from 0 to 2, then what we would have is 4 times 2 minus 2 to the second minus 4 times 0 minus 0 to the second. So that would give 8 minus 4. And then minus 0, so you would get 4. So 4 meters would end up being the displacement. And again, you don't have to do the absolute value just because of the area already being positive. Okay, the other way you could do this is like this. Okay, you could just take this function, and if you evaluate that at 2, well, you end up just getting this. You just have 4 times 2 minus t squared, so it's 8 minus 4, so it's equal to 4 meters. Okay, so either way is going to give you that displacement from 0 to 2. Okay, and that the reason why you can just plug in the 2 is because you're going from 0 to 2. Okay, and that's what's kind of important about that. So you could do that either way. Okay, so I'm going to look at maybe one more additional example on the next page. So let's read this one. This one says a ball is thrown upward from a height of 3 meters at an initial speed of 6 meters per second. Acceleration due to gravity, negative 9.8 meters per second squared. Neglecting error resistance, solve for the velocity and the height of the ball t seconds after it's thrown and before it returns to the ground. So let's work with this last problem. Okay, so the way I look at this, the first thing you're given is you're given the acceleration due to gravity, and that's a function. Ultimately, we're going to try to find the velocity. So the key thing you got to remember is if you do the derivative of the velocity, you get the acceleration. So if you do the integral of the acceleration, then that should give you the velocity function. So that's the way I'm going to look at this, is like that. So let's start with this. What we have to begin with is we know that v of t is going to be the integral of the acceleration function, like that. Well, we know what the acceleration function is. The acceleration function is given as just a constant, negative 9.8. So we're going to work out the integral of negative 9.8 dt like that. So let's go ahead and do the antiderivative just to get the function. And if we do that, well, that antiderivative is just going to be negative 9.8t plus c. Now this is an indefinite integral, so we have plus c. Now this is an initial value problem, so there's enough information in here to help you find that c. So the second thing I'm really going to do is I'm going to find c. Okay, and if you read this, it has an initial speed of 60. Now what that tells me is when time is 0, v of 0 is 60. Okay, so that is a initial value then. So what we have is t equals 0, v of 0, the velocity at 0 seconds is 60 meters per second. So all of that can be plugged in now. Okay, so what I'm going to do is just plug in the 60 in for v, so just plug in the 60 there, and the t would be 0. So you just plug in, then you'll have an equation that allows you to find c. So what we'll have is 60 equals negative 9.8 times 0 plus c. Therefore, the arbitrary constant is c. So therefore, what we end up with is this velocity function that we were trying to find is negative 9.8 t plus 60. Okay, that's an initial value problem. So it's really can be thought of as you're doing an antiderivative, but you're given an initial condition that allows you to find c. Okay. Now let's see. The second part of this problem says we want to find the height. Okay, and the height can be thought of as s of t. You know, s of t is a displacement, so you can think of that as a height. And the way that you get s of t, remember that if you do the derivative of s of t, you get the velocity. Well, now we know the velocity, so if we want to find s of t, we're just going to go in reverse. So what we're going to do is the height is going to be the integral of v of t dt. Okay, so we're getting the s of t, which is going to give you the height. Okay, so we need to go ahead and do that. So we're going to get h of t equals the integral of the velocity function, which is 9.8t plus 60. So we're going to go ahead and do the antiderivative on that then. So we're going to get h of t equals negative 9.8 t to the second over 2 plus 60t, and then again plus c. All right, you can divide that quantity on your calculator to get negative 4.9 t squared plus 60t plus c. All right, now we're going to see if we have an initial condition again. Let's kind of read the problem. Let's see what it has. So the other thing it says is, if you read this, it says the ball is thrown upward from a height of 3. That is implying at the beginning of time equals 0, your displacement or your height is equal to 3. Okay, so we're going to end up having this initial condition. T is 0, h of 0 equals 3 meters. So we're basically just going to go through and do the same thing. Plug the 3 in for the height, and then everywhere you see t, you're going to replace that with a 0. Okay, so it looks like what we get here is this all goes to 0, so that's 3 equals c. So therefore, h of t is going to be, you know, this answer we got here, but now we know what c is then. Okay, so we're going to have negative 4.9 t to the second plus 60t plus c, so that should be what your function is for the height. Okay, so that will wrap that up. Physics is always kind of nice to look at. Calculus, this is the motivation of Isaac Newton's development of calculus, is he was a physicist studying physics and gravity and things like that, and didn't have the right math to do it. Calculus is the right math, and it's what he needed, so he came up with it. Okay, so that'll wrap us up. Hope this helps you. Have good luck, and let me know if you need any help with anything.